So Bruce,
Yes.
oh, thank you very much for a fantastic presentation. That was really awesome.
Thanks.
That is great. So two questions. One is the logistics part. So do you prefer, if I have a doubt, to send a mail to you directly or open it as a ticket with NMR box?
So if you have, I guess if you're confident, like if there's an issue, if you're confident this is an issue and we're clear what it is, then I would go probably preferably rather than box, just because I already have an internal issue thing within our group, and then I have the GitHub site. So I would go to one of those to report an issue. Now, if it is if it seems like it's an issue, like there are a few idiosyncrasies running within Box. So if if you think, for example, I didn't show any 3D. We have a little 3D viewer in there, and there's some issue with it working right now in the box. So there are classes of problems that might be unique to running in the box, and if you're pretty confident that's the issue, then you could talk to the open as a box issue and CC me on it.
Okay.
If you're unsure about what, whether it's a problem or whatever, then go ahead and email me, or like I said, if we get the Slack channel going, that's probably a good place to do things too. But putting them in the issue tracker on GitHub means that I don't forget about them.
Okay.
If you email me something, I got to say it's a little bit embarrassing, but I know I've got issues that people have emailed me about, and emails come in so fast they scroll back. Whereas if I go to the issue tracker, then
Okay.
it's
Fair
there.
enough. Fair enough.
Important.
So there's one last question on that processing the data you showed, for example, the T1 and T2.
Yes.
If I basically pull the data from the MPK2 file, and if let's say if we started processing the data from nmrbox, now you said that there is a way, for example, to visualize that particular peak vis-a-vis the residue bar, the bar chart you showed.
Yes.
And suppose I find that particular cross peak is misbehaving. Let's say if I delete it there, does it kind of reflect in the does it update the XPK2 file or something? But that's like a two-step process, isn't it?
Yeah, it's to be honest, it's not as easy to do that, because I think it's cool we provide the ability to drill back, but we don't have the ability easily to actually remove a peak without going in and editing it out of the XPK2 file or saving an XPK2 file. I've debated, technically Ring and nmrfx are built with the exact same technology, and so in principle one could actually make one could pull all the code from Ring and run inside nmrfx, and then you would actually have everything talking to each other directly. And I haven't done that because they're kind of different funding streams. The Ring is funded by our CoMD P41 Dynamics thing, and the Ring and nmrfx is funded by MARA1. So I've kind of tried to keep them as separate projects, but it would be possible really to put them as a single program that and could be done separately, so they could run independently or could be integrated. Because like I say, the technology is the same.
But as an end user, if I have to therefore edit a particular, if I have to remove the peak, that offending peak, I basically go back to nmrfx, remove that from the peak list, save it, and go back and redo the fitting.
Yes, it's not as bad maybe as it sounds, because it's so easy. You just save the XPK2 file and then reload that project, and it will reread in the file. Just to, am I sharing my screen again? Yes. Just to, I don't know if I can exactly demo this interaction, and I'll explain why it could be a little bit tricky, but let me show you in principle what it has to do. In nmrfx, you come over here and you say new nmrfx server.
Okay.
And then in Ring, you come over here and you say connect to nmrfx server, and I see a message here saying it did successfully connect.
Okay, great.
And once you've done that, then under data, this button is active. If I click it, I get an error message because I don't actually have any data up and showing.
Oh, right.
I think the real tricky thing is the name of the peak list. You have to be sure that the peak list you're displaying like t1.xbk over here, and it knows it over here, so they're compatible with each other. And it can be kind of easy to save the peak list under one name and then load it here in a different name. That's the one thing that'll make it a little bit tricky. But otherwise, it's that easy to start the two up and just hit this button, and it will drive it to show you that peak. So
awesome.
I'll play with that a bit more.
Well, thank you. Yeah, thank you very much for everything.
Hi, Bruce.
Yes.
Hi, I have a question related to the peak picking in nmrFX.
Yes.
When you do that, so I'm considering like the relaxation experiments where you do a pseudo 3D.
Yes.
And when you pick on one particular plane,
yes.
Sometimes for the other planes, the peak shifts a little bit. So how is it handled?
Yeah.
Number two question.
Yeah.
Sorry if you. So it's kind of like related. When you have like overlapping peaks, sometimes. So what I used to do in my analysis, what I'm doing for test experiments, is that I'm forced to do peak picking in NMR draw, which is not a very intuitive method. And what it does is that it picks the peaks, and then it tries to fit the peaks intensities, and alongside picking the peaks, it also picks a like column where it picks, like, where it defines a cluster. So for example, peak 1, 2, 3, 4 may fall into one cluster. So they are named cluster 1. Peaks like 5, 6, 7, 8 fall into cluster 2, so on and so forth. And what happens is that at the next step, it tries to simulate the peak positions, like tries to simulate the spectrum based on the peak positions, and for individual clusters. So what it does now is that it actually helps deconvoluting the peaks. So is it done in the same way in nmrFX, or there's something different?
Yeah, it's certainly similar. I don't explicitly talk about clusters, but in fact, when there is some internal criteria, so that when I go to fit, there's something I didn't show. Actually, if you put your mouse down on the axis here, you can drag the spectrum. When it goes to fit a particular peak, like this peak, it searches and finds if there's a peak nearby. And so those will get fit simultaneously. I assume that's kind of the same as the cluster you're talking about. And because they actually, presumably those peaks have different decay, often we're going to have a little bit different decay rates. As you go through the multiple planes and are fitting the line shape, that means you have some additional ability basically to resolve their positions, I think. So I'm not sure if I answered the question exactly, but.
Okay, and what about moving peak positions?
Yes, moving. So that's a tricky one. So for years, it was still in nmrview-J, I have a mode. When I did the peak picking, the measuring here in the peak tool, I had intensities, volumes, E volumes. nmrview-J had something called jitter. And the idea of jitter was that basically you measured the intensity, the maximum intensity in the peak, and it looked in each plane to find if the maximum had moved less than, say, 25% of the peak width. And if it had, it picked the intensity at that new maximum. And so that allowed the peaks to move around a little bit. And so it has that advantage that it deals with the fact that the peaks may have moved a little bit. There's a whole paper was published that came out of Peter Wright and Jane Dyson's groups at Scripps. And a key part of that was arguing that that was a terrible idea. And the reason for that was that it's actually not so bad for intense peaks, but as you get near the baseline, getting down to very low intensities, the actual, the noise is a significant contributor to the intensity. And what you're actually doing by finding the nearest maximum peak is you're finding a noise spike, basically. And so the intensity of the peaks near the baseline were skewed. They were artificially elevated because you were finding a peak that was a nearby point that was high, not because the peak had shifted, because the random noise was important. And so they argued, really, you shouldn't, you shouldn't do that. But then that takes you back. Well, how do you deal with, I'm sure the answer that isn't a good answer, people wouldn't perhaps appreciate, because it can be difficult to run the experiments, and sometimes you run it and realize it. But the more you can interleave during acquisition, so that
there's no temperature change.
It's and the temperature change isn't a given plane relaxation time. Not every row was collected at the same time, etc. So you sort of average the temperature shifts across all the planes, and there isn't a systematic shift. There's maybe more of an average.
But this happens when you are doing like titration experiments, when you actually measure multiple samples.
Yes.
And you're trying to fit the data to some sort of like model.
Yes.
Where the peaks also might change in position along with their peak intensity.
Yeah, same thing in finding the position of a peak in a titration. But and again, there we actually find we use the local maxima of the peak. Although we do fit the few data points around the maxima. I haven't tried in a titration to actually do the line shape fitting to see if that would actually help or not. In titrations, oftentimes the intensities maybe changing at the same time the peak is moving, and they make kind of weak sometimes. So your accuracy at finding the peak could suffer sometimes too. So
one way to get around is that giving the user the ability to change the peak positions manually,
that is explicitly, and like I say, I'm bummed that the titration system didn't work. The idea, I've showed the little arrows that you can do to step through each data set / peak for a given experiment. So you can go to step through to a given peak and then say, that rather than seeing them all sort of on top of each other, you can actually easily select an individual peak and drag it a little bit back closer to the whole titration curve. I'm sure there are long philosophical arguments as to whether that's acceptable or not, but sometimes you can see that it's skewed in the wrong position. You can see the reason why it was there. Probably not so bad to move it where it ought to be, but a little tricky.
Right. Thank you, Bruce.
Yeah. Any other questions or things people want to see?
If nobody has any question, can I ask one more?
It's fine with me.
So when you're talking about the global fit for the R2 data, or any sort of relaxation data, knowing that two regions of the protein are linked by a disulfide linkage, or something like they're close together. Can you elaborate a little bit more on that, like how it is done?
So here I've put up that BPTI data. It really just comes down to, and we'll just do a subset of the residues here. Oops, hold down the shift key. If I fit these guys, it really just comes down, and it's only, the only complicated thing is that there's bookkeeping underneath that in the code that decides what parameters are floatable across all the residues. But the idea here is that something like the chemical shift change is going to be different for each residue. They're each in a slightly different chemical environment. So that parameter dppm for, and you can see, you know, I've got the 4 residues, 36, 38, 39, 40. The chemical shift change has to be independent. Whereas the exchange rate, we're basically, in the fitting equation, there is just a single parameter for exchange rate that applies to all the different residues. So like I say, it's kind of a pain at the coding level to sort of handle all the different combinations, but really it just comes down to a question of which parameters should change. And some of it comes down, is a little bit tricky and theoretical. For example, it's pretty obvious the chemical shift change is independent in different residues. KEX, the whole idea is we're exchanging with the same phenomena, so that's going to be the same. The population has to be the same. If they're exchanging it the same way, then you can't have one residue in one state and one residue in the other state, or they wouldn't be moving together. The R2 value here is the relaxation rate at infinite constant, or infinite, you know, at no exchange. So I guess that's not ambiguous either. It gets a little more, I guess the ambiguity that I was thinking about and got confused by is whether you allow R2 to be affected by the magnetic field, because you can be fitting these values at different magnetic fields too, and what parameters float by magnetic field, or what parameters are held constant is another one. So here we've allowed R2 to be independent for everything, and we allow it even across different magnetic fields. Because this is data not only at multiple residues, but on a 500 and a 600. So we've got R2 values that are present for individual residues and have different values for the 2 different magnetic fields. And sometimes you can assume that they're going to be the same, but that's more of a theoretical question. Not sure if that answered.
Yeah.
But most of it comes down to deciding which parameters, you know, deciding. We have not put in, and some software has the ability, we could add some clustering software that basically says, you know, group together residues by their common exchange rate and suggest to you which ones should have. We don't provide anything like that at the moment to really let you decide. And you can see the exchange rates vary quite a bit. And one thing that's one of the scariest things I find about all this fitting are coming up with reasonable error bars. You can see that these 2 residues, 12 and 14, I'm looking at, really differ outside of the error bars. So their error bars are not overlapping. This guy's quite a bit different, yet I can include it in the global fit, and it fits, you know, quite well. So giving realistic error bars is a real challenge. And we didn't have time to talk about it. We have actually multiple ways listed in the optimizer here, this non-parametric versus parametric error bars, whether we're fitting absolute value, how many bootstrapping samples to do. So there's quite a bit of stuff we tried to do to make that reasonable, and there's still things I want to add to it, but that's the most complicated part. Can you really believe these numbers plus or minus a certain error value, and what is that error value? Yeah.
Hey, Bruce, it's Doug.
Hey, Doug.
So, you know, I've been using nmrbox20 for a long time, so I have lots of projects, right? And I think we've talked about this a little bit, but
yes,
you've mentioned that it's not directly, you're not directly able to read in projects from J into nmrfx.
Yeah,
and so is there a possibility of at least kind of stripping out some basic information from nmrbox20, like peak lists, chemical shift values, and in particular, even paths to the data, so that I don't have to go back through and read in all that data?
Yes. So this is one thing actually I really should have talked about. There is the whole idea of projects. So if I go into Summer Workshop 2020 and I go into Johnson and I go into Ubiquit Assign, which had all the stuff I was going to show for Runabout X that we didn't get to. Ubiquit Assign is actually a project. And I didn't talk about projects at all. There is a whole project menu, and this is really the way you save your data. You basically come up here to the projects, and you do save a project. There's a open recent projects. And what a project is basically a folder containing several folders, which is the same thing that nmrbox20 did. There's a data sets folder that has the actual data sets in it. Data sets, a little, I don't know, sometimes I may have been trying to be too clever here. These data sets in the Unix world are hard links. So if you actually open a data set some other place on your disk drive and then save a project, it actually saves a link in the project so you don't have, it looks like you've got a copy of the data set in this folder, but in fact, it's really just a pointer to the original location. But it's a so-called hard link. So actually, if you get rid of the original location, it's still here. So there's a datasets folder. There's a molecules folder, which I think we'll probably get rid of. There's a peaks folder. There's a shifts folder, but really the important thing is there's a star folder. And oops, ls star. Oh, I'm in peaks. ls star. I guess I didn't save any star files in here yet. So just like nmrbox20, the basic, most of the information is stored in a star file, a BMRB star file. And so in fact, and I haven't tried every possible one, but I've copied a number over from nmrbox20. In theory, you can just load the star file and you'll get the molecular structure, you'll get a list of the data sets, you'll get the peaks, you'll basically get everything you're talking about. What you don't get are windows. Both of them have a way to sort of save, like if I'm in a project and I click this favorites button, I'm going to save a sort of a file that saves the state of that window, and I can go back to a Spectrum favorites and get a list of all the favorites and quickly reload them. NVJ did that too, and the format of those Windows files is different, so those wouldn't come across. But in theory, the star file is going to have most everything. In theory, the star file should open here.
Okay, sounds good. But maybe the only thing that won't transfer is like all the runabout progress, I guess?
Yes.
Okay.
There is a kind of a kludgy sort of runabout save frame in the star file, and that won't come across. Because I'm working on new runabout, that's kind of like in the middle of things right now, and I really need to see if I can make it so as much stuff as possible that was done on a runabout project could come across. So I'm going to
if I were to read in a star file that had runabout information, would it just ignore it in NMRFX, or is it going to give me a
it should just ignore it.
Okay.
It'll have all the peak lists. It'll have any assignments you've done. It should have the fact that the clustering that was done in the cluster phase of runabout should still be there. Whether you've confirmed one cluster to overlap another cluster, I'm not sure, because I'm kind of still deciding how that actually happens in runabout, or in the new runabout. One thing I will say that is different about projects, if you looked in the star file of or the star folder of an NVJ project, you'd have like 50 star, every time you save the state of the project, you'd have a star file. And they would increment. They could get quite large and take up a fair amount of space. Anybody that's familiar with Git, which is a version source code management system that actually is being kind of widely used, and there was an article in Nature the other day about how lots of labs are using Git to manage just data and things like that. So an NMRFX project is actually a Git repository. And so every time you do a save, it does a Git commit. And so you only see one star file, but you can actually, and this is what we haven't given you GUI tools in NVJ, you can actually replay the history and go back and branch that, and you know, but it looks like there's only one file and you've saved a lot of space because the only thing that really saved, that you let Git save the difference between files rather than the actual files.
That's great. Actually, I used to go through and just gzip all of my old backup files.
Because they did get pretty big, and so this actually gives you kind of a log and history and ability to say, I want to go back to a week ago and try my assignments in a different way with a different branch, you know, at the branch. Like that's not really, it's there. They are Git repositories now, but we haven't given you any tools. You could actually go in and use Git from the command line and do stuff. We haven't given you any tools inside nmrfx, but on the proverbial list.